All right, guys, let's talk more about similarity. So on 67, we got this triangle similarity stuff. Remember, we can use angle-angle similarity. So I'm just looking for two pairs of congruent corresponding angles. So in this picture here, like A might be the same as D, and then B might be the same as E. And if I notice that, then I can use angle-angle. Or we can use side-side. Oh man, why didn't I match these up? Ugh. We can use side-side-side. Now with side-side-side, all three sides need to be proportional. So this is
Jordan
annoying.
Buckner, please report to the 700 call. Jordan Buckner, please report to the 700 call. Your brother's waiting.
Whoops, we're gonna go with it. I need all the sides to be proportional. So I can choose how I write the ratio, but maybe I do side AB. Actually, let's get color here. So side AB matches up with DE. And so I could write the fraction AB over DE, or I could do the reciprocal, but that would have to be the same as BC matching up with FE. So has to be the same as BC over FE. And that would also have to be the same as the last one. So AC and FD. Now, a couple things to point out. Across the top, we have all the same triangle. And then across the bottom, we have all the other triangle. And then like top to bottom, when I'm going up and down, they're like corresponding to each other. Like they match up. And it's kind of hard to tell when like things aren't numbered because like when they're numbered, I can do small with small, medium with medium, big with big. Or if the similarity statement is already there for me, just by looking at a picture, it's sometimes hard to tell like what they actually intended. And then last but not least, we can do side angle side similarity. So that has two proportional sides, and then the angle in between is the same. So maybe I know that AB and DE match up, and AC and FD match up proportionally. So like AB over DE is the same as AC over FD. And I also need that the angle in between is congruent. So angle A equals angle D. You need to have both. Proportion and equal. Okay, now there's just a whole bunch of them in here. Boop, 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 ba-doop. Let's go. So with this one here, I can use angle-angle similarity because rainbows, 80s. So triangle ABC is similar to triangle. So I went 1 to 80 to none. So 1 to 80 to none by angle-angle similarity. Okay. So these two triangles, the small and the big, are similar by angle-angle because of the parallel lines. That's enough to tell me. And so since they are, the sides will be proportional to each other. So I can match up the 8 and the 12 because they are opposites. And since I'm matching up the small to the big, I have to do the same thing here. So the small triangle here has this side X on it. And then the big one that matches up with is that whole thing, which, like if it was 5, then it'd be 11. Or if it was 4, it'd be 10. And so like what we're doing there is we're adding those two things. So when I write it down, I want to make sure that I add them. And so then we can cross multiply and solve. So I'd have 12x equals 8x plus 48. Subtract the 8 over, so we'd have 4x equals 48. So x is 12. Oh my God, I love it. That's 12. And then the whole thing's 18 and 12 to 18. Okay. Same idea here. These two triangles are similar because of the parallel lines. I get angle, angle, and I have vertical angles. So we can match things up. So the parallel lines are going to match up with each other because they're like opposites of each other. So the 3 over the 5. And since I'm going from this triangle to that one, we have to do the same thing here. So x plus 1 over x minus 2. And then we can cross multiply and solve. So 5x plus 5 equals 3x minus 6. Subtract your 3x, subtract your 5. Oh my goodness, it's always concerning when you get a negative. So we get 2x equals negative 11. But I mean, we did all of our math right and divide by 2. So x is negative 11 over 2. Yuck. Math is what it is. Alrighty, jumping down here. Now we want to see, mainly because I don't see many x's here, are they similar? So I have sides matched. We want to see if they're proportional to each other. So I'm going to go this first triangle on top and this one on bottom of my fraction. And I'm just going to go in order from smallest to biggest. So 6 over 12. Is that the same as 7 over 14? Which is, are those the same as 8 over 16? And they all are because they're all half. And so we could say that triangle ABC is similar to triangle, so A to B to C, D to E to F, by side, side, side. Similarity. On this one here, I can actually tell that these two triangles are similar by side, angle, side, I think. Oh, I guess I could do side, side, side. Oh, I could do side. Well, let's see. Are they? I don't know. Because if they are, then I'll know that x is congruent to whichever angle this is over here, because those would be alternate interior, maybe. Again, if this actually is similar. So, I don't know. We got to find out. So let's do side, side, side. So if I do the smallest side here, 6, paired up with the smallest side here, 4, is that the same as 7.5, that middle side, with the 5, which is that the same as 9 over 6? And these sure all are, because they are all going to reduce to 3 over 2. So since that's the case, I know that these triangles are similar by side, 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 but that also helps me to know that all the angles will be congruent to each other. So the 40 goes here, and then the 80 would go, because they're going to match up at the M and the O, the 80 would go there. And then I can use the triangle sum theorem to find out x, because they would all have to add up to equal 180. And so that tells me that x would have to be 60 degrees. And again, that's because all the angles are congruent in similar figures. They don't have to be proportional. And then last but not least, if we're going to go this first triangle on top, second one on bottom, and then small to big, we'll have 5 over 10. Is that the same as 12 over 24? Ooh, it's looking good so far. Half, half. And then 13 over 26, also half. So yes, they are similar by side, side, side similarity. So triangle QRS is similar to triangle QRS. I want to cross small, then medium. So STU is how they would match up. Last but not least, totally looks like a side angle side thing going on here as well, on here as well. And so since that's the case, we just need to make sure that those proportions match up. So on this one here, 6 is smaller. That's got to match up with the 15. And then is that the same as 8 over 20? And I don't know, maybe we'll reduce, like 3 goes into both, so 2 and then 5, and then 4 goes into both, 2 and then 5. So yes, they are similar by side angle side. So triangle ABC is similar to triangle DEF. That took me a long time. Next one here, I can see side angle side, but I have to check and see, are the sides proportional? So on this guy here, the smaller is 5, which would match up with the smaller here. Is that the same as 6, which matches up with 5? Those are not the same. And I can't reduce. And if I cross multiply even, I get 25 and 24, and those aren't equal. So not similar. And it's always good to see a not example. So looks like I might have side angle side here. I definitely have that the angles are congruent because they're vertical, but I have to see, like, when I write the ratio, do they match up? So if I go with the smallest side here, that's 15. Matching that up with the smallest side here. And again, it would have to be the 5 or the 7. It can't be the 4 because that doesn't correspond. So the 5. Is that the same as 21 over 7? And it sure is, because that reduces to 3, which would mean, so really 3 over 1, that would have to be the same ratio as these two sides. So we started with this triangle, so x over 4. So to solve for x, I times by 4, and it would have to be 12. Because this is all just 3 times as large as that, which is kind of easy to see because it's just times by 3, but it's when you get those like times by like 7 over 4, like, no. Anyways, good luck.